Hey, it's Mr. Allred here, and we're going to solve a practice problem with absolute value inequalities. And the one we have here on the left is the absolute value of x over 2, and that's minus 5. All of that is less than or equal to 13. So one thing to notice here is that I have the absolute value all by itself on the left hand side, so I don't have to move anything around. So the important part here, once it's by itself, is two things. One, if it's going to be less than, which is definitely here and it's important, it needs to be less than a positive number to make sense, and it is. So with the less than, remember that's a compound inequality, so I'm going to break that apart. I'm going to have the x over 2 minus 5 in the center. That's going to be less than or equal to 13 on the right, but it's going to be negative 13 less than or equal to on the left. So it's trapped between the positive and negative value of 13 here. And you can solve this many ways. It may not make a big difference to you, but if I have fractions anywhere, I like to get rid of those. So I'm going to multiply everything by 2, since the only denominator I have is 2. So that'll be 2 times negative 13, which will be negative 26. That'll be less than or equal to 2 times x over 2. The 2's would cancel out, so just be x. 2 times negative 5 will be negative 10. And then that'll be less than or equal to 2 times 13, which is 26. So now we have x minus 10 trapped between positive and negative 26. Okay, and it doesn't look like we're going to have to go back and visit fractions from the way this looks, so that's good for us. So here we're looking at a compound inequality. Our x is in the center, that's good. Keep in mind we're trying to focus on getting that x by itself, so that's our target, get that x by itself. So we need to get things away from it. So we need to add 10 to cancel out the negative 10. But if we do that, we need to do it in all three parts. So we'll add 10 to both sides. So in the end we get negative 16 less than or equal to x less than or equal to 36. So our values for x, or our solutions to the inequality that we started with, are numbers between negative 16 and 36. And while we do inequalities, I like to go ahead and emphasize all three notations to keep you up to date with it. It might seem like overkill, but when I give a test, I like to ask for all three. So if I do it every time, maybe it'll stick with you. So x is between negative 16 and 36, so we can put those in there. Less than or equal to, so that is a bracket. X is less than or equal to 36, so that's another bracket. So we have a bracket from negative 16 to 36 with everything in between. And then that goes over to interval notation with bracket negative 16 as a starting point and to 36 bracket as an end point. I don't know that I've said it enough, but keep in mind these brackets and these less than or equal to, greater than or equal to, means that if we plug negative 16 in, it should make this inequality true. Whereas if it was just a less than without the equals to, negative 16 wouldn't work, but things in between the interval would work. So let's make the point of that. All three notations.